Alright, hi students, now we have come to the last part of this chapter, which is perhaps the most important one, and that is how do you actually draw what we call the electronic structure of an atom. This particular concept will be the fundamental concept for the subsequent two chapters on bonding itself. Alright, so let's take a look at the notes. Alright, if you take a look at the notes, you realize that the first point itself is saying this thing about the electronic arrangement, electronic structure, and electronic configuration. These are three terms that can be used to describe this term that we just mentioned just now, electronic structure, and they are interchangeable. So the question can use either one of them, and they're actually referring to the exact same thing. So why must we know how to draw the electronic structure of an atom? Firstly, it's important to know how the electrons behave and they are arranged in an atom, because that will determine the chemical properties of the atom. For instance, how reactive and as what we mentioned previously, electrons are always orbiting around the nucleus in regions that we term as the electron shell. It's important to know that each electron shell has a specific amount of energy and it can hold a specified maximum number of electrons. This will actually form the basis of the electronic structure that we will be teaching you on how to draw or how to write. And now we'll move on to learn about how to draw the electronic arrangement, structure, or configuration of an atom. Let's take a look at this diagram over here. So you'll notice that in this diagram there are certain rings of structures and there are certain dots that you see over there. The dots refers to the electrons themselves. Okay, so this is how we will depict the electrons, and this is the electron shell. Alright, AR is the chemical symbol for which element. Do you know? You can refer to the periodic table to find out which element it is. Now, having clarified about these few points, let's take a look at what is the number of electrons that each shell can hold. The first shell, the innermost shell that you see over here, can hold a maximum of 2 electrons, and it will be always filled first before any additional electrons. How do we draw the electrons? We usually draw it in opposite manner, so you have one over here and the other one will be on the other side. The second shell can hold a maximum number of 8 electrons, and it's only filled after the first shell is filled. And how do we draw these 8 electrons? We can go with a simple method of what we term as north, south, east, west. So we use this short acronym to remind ourselves on how to draw the electrons. So this is how I will start drawing. The first electron, north, second one, south, third one, east, fourth one, west. Now the fifth electron, same thing, north, south, south, east, and west. Alright, so we always fill up the north, south, east, west first before we go on to pair the number of electrons. Okay, so now the third shell. The third shell can hold a maximum number of 8 electrons, and it is only filled after the first and second shell are filled. Okay, so it's the third shell will only be filled after the first and second ones are filled. How do we draw the electrons? Similarly, following the north, south, east, west method, we'll start with the north, south, east, west, and the north, south, east, west. And that is how I will depict the electrons in this structure that we term as the electronic arrangement or electronic structure or electronic configuration. Now let's have a bit of practice. Over here you see 2 boxes. You're required to draw the electronic structure of a hydrogen atom. So go to the periodic table, take a look at what is the number of protons and eventually the number of electrons of a hydrogen atom, as well as for a nitrogen atom. Okay, in the periodic table, the hydrogen atom is represented over here. And you'll notice that, remember, in the periodic table, the proton number is the number that is at the top. So, this is the proton number. If hydrogen atom has 1 proton number, do you remember how many electrons should it have? Yep, since it's an electrically neutral atom, it will also have 1 electron. Now, since hydrogen has 1 electron, let's take a look at how do we draw the structure. We'll start off by writing the chemical symbol in the middle, followed by a ring around it. This is the first shell. Since hydrogen only has one electron, we can draw the electrons over here on the north position. And that is all we need to do. This is for the hydrogen atom. There won't be a second or third shell because it only has one electron. Now let's take a look at nitrogen. Try it out by yourself. There's a nitrogen atom with the chemical symbol. How many rings of electrons should it have? Right, if you derive from the periodic table, you'll notice that nitrogen should have 7 protons, and since it is an atom, it should have 7 electrons. And let's take a look at how do we draw this. After the first shell, you have to include the electrons. So out of these 7, there's 2 of them which will include in the north-south position. Because the first shell can only hold 2 electrons, that's the max we can go. And we'll move on to the second shell. There's 5 more electrons out of these 7, so north, south, east, west, and north. And that will be the electronic structure that you draw for the nitrogen atom itself. Okay, you notice that there's 2 electron shell, and the outermost shell has only 5 electrons. Right, now that you have seen some examples, it's time to try it out by yourself. So let's take a look at some example question. You can take about maybe 2 to 3 minutes per drawing and try to derive the electronic structure for this following. Just draw it on a foolscap or a rough paper at the back of the page. These 4 elements that you see over here. Refer to the periodic table to find out what are their proton number, using that to derive the number of electrons and then to draw the electronic structure itself. Remember, this topic based a lot on practice itself. As long as you can get the gist of it, then you should be able to do all the subsequent topics very easily. Alright, now it's time to test yourself. Given 5 minutes, can you go on to the last page of this set of notes, the A3 size periodic table, draw out the electronic structure for these 6 elements. First of all, you need to identify where do they exist on the periodic table. Use that to derive the proton number and eventually the number of electrons. Good luck! So now that we have covered so far in terms of the electronic structure and you have did so many practices, let's take a look at a few more concepts. Okay, so first of all, the electron shell that's the furthest away from the nucleus is also known as the valence shell, or sometimes we call this the outermost shell. And the electrons in this shell are known as the valence electrons. So, in other words, the term itself, valence, actually means outermost. So if you take a look at the structure that you see just now, the outermost shell for the hydrogen atom is actually this shell. Okay, this is the valence shell for the hydrogen atom. And for the nitrogen atom, the valence shell is the outermost shell, which is this one. This will mean that all these electrons that you see over here, that I am now shading it in red, are what we call the valence electrons of the nitrogen atom, because they are on the outermost shell. Why is this important? Because the chemical properties of an element actually depends on the number of valence electrons. Okay? This is a concept that will keep recur in the later chapters on how come certain substances, certain elements are able to react in a certain manner, whereas the others can't do so. It's actually dependent on this concept of the number of valence electrons. Alright, so sometimes in the electronic structure itself, right, we only draw the valence electrons. Okay, we don't draw the innermost electrons. And this type of structure are what we call as the outer electronic arrangement structure or configuration. Notice this word over there, outer, because it only shows the outermost shell, as you can see over here in this diagram. The opposite of this is what we known as the full electronic structure. So for carbon atom, this is how it looks like. North, south, east, west. Right? You realize that there's the innermost shell for this structure. What if the question only asks you to draw the electronic structure? That means it didn't specify whether they want the outer or the full electronic structure. In this case, you have to draw the full electronic structure. North, south, east, west. Alright, so that is what we mean by drawing the electronic structure or arrangement or configuration. Now we move on to the writing of electronic structure, arrangement or configuration. Notice that the difference between these two segments that you're learning is just whether you're being asked to draw or you're being asked to write. So it's either drawing or writing. Okay, and it makes a lot of difference, okay? Because for writing itself, right, there's no need for you to draw all the electron shells anymore. You represent it using this manner. The first number actually represents the first shell. The second number represents the number of electrons in the second shell. And the third number represents the number of electrons in the third shell, okay? So looking at this is for argon. We saw just now that in argon, the electronic structure itself, there's 2 electrons in the inner shell, followed by 8, followed by another 8 on the third shell. So when you write out the electronic structure, it'll be in this manner, 2.8.8. And by this, you'll know that the atom has a total of 8 valence electrons, because this third shell is the valence shell. In addition, you also will learn that this element actually belongs to group 0. Why is it group 0? We'll talk about this at a later part of the last page of this particular note. And how many electron shells does this element has? It has a total of 3 electron shells, shown clearly by the numbers that you see over here. Last but not least, which period is this element found in? And in this case, it's actually period 3. Now, how do I know that is found in group 0 and period 3? In order to answer your question, I would like to get you to complete the entire A3 periodic table that you find at the back of your notes. Draw out all the electronic structure, write down all the electronic structure, and try to spot if there's a pattern within this entire periodic table itself. And this will be revisited when you come back to school. So, with that, we have actually come to the end of this chapter. We have started off by talking about what exactly are your protons, neutrons and electrons, where can they be found in. We then move on to talk about these 2 sets of terms, the proton number as well as the nucleon number, how to derive them based on this concept about the atomic symbol, how to look at this symbol and derive the different numbers. We then went on to discuss about how to calculate the number of neutrons based on the nucleon number. If you recall, nucleon number is equivalent to the number of protons added with the number of neutrons. Alright? Next, we also talk about what exactly are isotopes. Right? Isotopes are the atoms of the same element with the blanks over here should have already filled up, okay, based on what you copy down in the notes itself. Okay? So, they are atoms of the same element with the same number of protons and electrons but different number of neutrons. We talk about a few examples of your isotopes. How to calculate the mass number. Alright, this part is very important. It's calculated based on the relative abundance of each type of isotope, and you must know how to apply the formula in this case. Next, we move on to talk about the key concept of this topic, which is how to draw the electronic structure of an atom. We talk about drawing, we also talk about writing. We talk about how many electrons can each shell fill up to, and of course, with more practice, you should be able to master the number of electrons that you should draw when given a particular element itself. So with that, we have come to the end of this topic itself. Please complete the notes or worksheet questions that have been assigned to you before you revisit this topic with your teacher back in class.